India's first animated live tuition. Can you hear me? Okay, so please turn on your camera. Everybody, please turn on your camera. Okay. Please switch on your camera, everyone. Yeah, good evening all, good evening. Okay, so today we are, how are you doing? Yeah, fine, thank you. What about you? Hello. Do we have some new students today? Any new student? Please raise your hand. Number system, yeah, I know. We can start the chapter, okay? Any new students? Yeah, we have a hand raise, ma'am, too. Okay, please unmute and please introduce yourself in 2 sentences. Can you? First one is?
I don't know how to pronounce
Okay,
it.
so please unmute him. Hello.
Hello.
Ha, what is your name?
No, my name is Varnita.
Okay, so and you are from?
I'm from Tamil Nadu.
Tamil Nadu. Okay, welcome to the class. Yeah. Okay, and then Ashwin. Here. Ashwin, please switch on your camera. I can't see your face. Please switch on your camera.
Hello.
Yes. Hi, Ashwin.
Hi.
So this is your first class?
Yeah.
Okay, and welcome to the class, Ashwin.
Yes, ma'am.
Okay, and what happened, Sanjit? He's not new. Yeah, any doubts? I'm fine. What about you?
We got a point on this chapter now. Why did you switch to number system?
Okay, many of you were asking about this number system, and like in the exam and all, you have this number system. So many of you you were there in last class, right?
Yes, ma'am. I was there in many classes.
Yeah, okay, and many of you asked about this number system, so that's why I just switched to number system. We will continue with the polynomials after this. Okay, after completing number system, we can continue with polynomials. Okay?
Okay.
Yeah. Okay, so number system is the first chapter, and many of you were asking about this chapter. Number system, we want to study this chapter. Yeah, okay, so let's start the class. Ready? Okay, so the first thing is number system, and here you can see so many numbers. Okay, yeah, and now let's list them one by one. Here I have 1, 2, 3, etc. Can you tell me some specific name for this group? 1, 2, 3, 4, etc. They are known as? Yeah, hand raise.
Hannah.
Yes, Hannah.
Ma'am, it's natural numbers.
Natural numbers, very good. And we use a letter to denote natural numbers, which is that alphabet.
N.
N, very good. So this set 1, 2, 3, etc. These numbers are known as natural numbers, and we use this letter or the alphabet N to denote this natural numbers. But after that, I'm adding one 0 along with this numbers. So it's like 0, 1, 2, 3, 4, etc. So this set of numbers is known as, next one, ma'am.
Okay, this one. Ashlyn.
Yes. Yes, Ashlyn.
Whole numbers.
Whole numbers, and we use one alphabet to denote whole numbers. Which is that alphabet?
Is it W?
Yes, it's W. So this is the second set, whole numbers. Along with natural numbers, we are adding one more number, which is 0. And 0, 1, 2, 3, 4, etc. is known as the set of whole numbers. Which is the smallest whole number? Smallest whole number?
Chris.
Yes, Chris.
0.
0. And the smallest natural number?
1.
1. Largest natural number?
There was infinitive.
Yeah,
so
okay.
I
Yeah, very good, very good, very good. Okay, now after this 0, 1, 2, 3, I am also adding this negative numbers. So it's negative infinity, then negative 2, negative 1, 0, 1, 2, 3, 4, etc. So negative infinity to positive infinity. We have all the negative numbers, positive numbers and 0. This set is known as the set of
Hriday?
Yes.
Yes, ma'am. It is integers.
Integers. And we use one alphabet to denote this integers.
It's Z, ma'am.
Yes, very good. I thought you were going to tell me it's I. Yeah, very good. So we use this letter Z to denote the set of integers. So it starts from negative infinity and goes up to positive infinity. So negative infinity to negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, etc., etc., up to positive infinity. Yeah. And after this, we have another set which includes all the numbers of the form P by Q, where P and Q are integers. To be precise, they are co-prime integers, and this Q is not equal to 0. Okay, suppose we are drawing a number, we are drawing a number line. We have the 0, 1, 2, 3, 4, etc. Everything is there. Here we have negative 1, negative 2, and it goes up to infinity. And in between the 0 and 1, we have 1 by 2. Okay, what about such numbers? They are known as this numbers of the form P by Q. They are known as? Yes, ma'am.
Grisha?
Okay.
Non-rational.
Rational numbers. Very good. They are known as. And what about the alphabet which denotes rational numbers? Is it R?
U.
Q. Very good. Ma'am, I just joined. What did I miss? Nothing. We just started. Okay. So here we have natural numbers, that is from 1, 2, 3, 4, etc. up to infinity. Then whole numbers 0, 1, 2, 3, 4, etc. Then integers, we just discussed this. Okay, number system. Natural numbers, whole numbers, integers and rational numbers. Always remember this thing. It's like natural numbers, then whole numbers, integers. Okay. Natural numbers, whole numbers, integers is not I, it's Z. Okay, integers, then we have rational numbers. Okay, so my statement is all natural numbers are whole numbers. True or false? All natural numbers are whole numbers. Is it true?
R is?
Okay.
When did the class start?
Indian time 8:30.
India time 8:30.
Yeah.
Oh, okay.
Okay. So my statement is all natural numbers are whole numbers. Okay. We can unmute someone more, ma'am. All Yes. All natural numbers are whole numbers. True or false?
Yes, ma'am.
Yes, true. Okay, so all natural numbers are whole numbers, and now all whole numbers are natural numbers. All whole numbers are natural numbers.
Ashwin?
All whole numbers are rational numbers.
Like my statement is all whole numbers are natural numbers.
False.
False. Okay. And now what about next one? All integers are rational numbers.
Neha?
Yeah, all integers are rational numbers.
Yes, true.
Yes, true.
Integers are rational numbers.
Yes, all integers are rational numbers. What about the other one? Like all rational numbers are integers. Is that true?
No, because integers cannot be expressed in the P by Q form.
Yes, very good. So see this, it always goes up. Okay, all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, then all natural numbers are this rational numbers, all whole numbers are also rational numbers. It always goes up. Okay, if it is N, then W, Z and Q, the connection is always like this. It always goes up. Okay, never goes down. If the statement is all rational numbers are natural numbers, that is false. It always goes up. Okay? Never goes down. Yeah, so progressive. Always goes up. So all natural numbers are whole numbers. Yes, that is true. Then all natural numbers are integers. All natural numbers are rational numbers. That is always true. But if the statement is all rational numbers are natural numbers, that is false. Okay, it always goes up. Yeah. So you know about this natural numbers, whole numbers, integers and rational numbers, right? Now let's define a rational number. Okay, so what is a rational number or what are rational numbers? Any idea about rational numbers, ma'am? Irrational numbers, yeah, we can learn that. That is the second topic. This is the first topic, and after that we can learn about this irrational numbers. Okay, it is actually another set, right? It is that is not related to the set of rational numbers or this integers. It is another set. Okay, yeah. So we will learn about that after completing this rational numbers. So what are rational numbers? We can unmute someone and ask them what are rational numbers. Any idea?
John.
Yes, John.
Yes, ma'am. So rational numbers are numbers which can be represented in Cbse form, where q is not equal to 0.
Yes. And what about this P and Q?
P and q should be integers.
Yes. Okay. So we have this P by Q form. Whenever we hear about what this rational numbers, we have this P by Q form. So we have this numbers of the form P by Q, where P and Q are integers and Q not equal to 0. Such numbers are known as rational numbers. So what are rational numbers? Any numbers of the form P by Q, where P and Q are integers and this Q is not equal to 0. So P can be equal, wait. P is not equal to 0. Is that true? Or P is equal to 0? Our condition is Q not equal to 0. So can this P equal to 0?
Rishikesh.
Yes. P can be 0 or P cannot be 0.
P can be 0.
Yes, very good. So P can be equal to 0, but this Q is not equal to 0. It is never equal to 0. But why we are insisting that this Q is not equal to 0? What happens if this Q is equal to 0? Any idea?
Azalfa.
Okay. Yes.
Now, what's the question?
A question is, I have this 1 by 0. Okay, here Q is equal to 0. And our condition is Q is not equal to 0. Why we are insisting that this Q is not equal to 0? What happens if this Q is equal to 0? That is my question.
If the rational number to convert into a decimal, we have to divide the numerator by the denominator, and we cannot divide by 0.
Yeah, division by
That's
0
why
is
the-
not defined. Yeah, division by 0 is not, sir. Can you please remove that? Okay, so a number of the form P by Q, where P and Q are integers and Q not equal to 0 is called a rational number, and we insist that this Q is not equal to 0 because the division by 0 is not defined. That's why we have this condition. Q is, can you go to the previous slide? Okay, wait. Just take a screenshot. Natural numbers, whole numbers, integers and rational numbers. Okay. Yeah. So rational numbers are any numbers of the form P by Q, where P and Q are integers and Q not equal to 0. This is a rational number, and we insist that this Q is not equal to 0 because division by 0 is not defined. So this Q cannot be equal to 0, but this P can be equal to 0. Okay, that is the definition of a rational number. So the next question is, what about this rational numbers and what about this Q? Here, if it was a natural number, okay, natural number, we denote it by the letter N. Okay, and here it is first letter, first alphabet. Okay, and here it is rational number, but we use this Q to denote. What is the reason? Q denote quotient. Okay, the rational number came from this word ratio. We are taking the ratio. Okay, P by Q form means actually we are taking the ratio. Okay, 1 by 2 means actually the ratio of 1 and 2. So P by Q we are taking the ratio. That's why it is rational number, and we use this Q because it is quotient. Okay, again it comes from this P by Q, everything, the name, this alphabet, everything. Okay, yeah, that is there in your textbook. That's why, just for your knowledge. Okay, yeah. Then is negative 25 a rational number? We have this definition. Rational number is any number of the form P by Q where P and Q are integers and Q not equal to 0. So is negative 25 a rational number? This is not. Can you show the previous slide? Yes. Okay, so here this negative 25, is it a rational number? This is just negative 25. If it is a rational number, it must be in the form P by Q, no? So this girl is confused. What about you? You are also confused? Yeah, let's unmute someone, ma'am.
Sanjit.
Okay, Sanjit. Is negative 25 a rational number?
Yes, ma'am, it is a rational number.
Why?
Ma'am, every natural number is a rational number. And
So
every
is
integer
this
is a
negative
rational-
25 a natural number?
Yes, ma'am, because down there will be 1.
Yeah, this is a natural number.
No, this is an integer.
Integer. Okay. So negative 25 is an integer. Yeah, that is true. Then what about this P by Q form?
Yes, ma'am, it is under every number there will be 1, ma'am.
Yes.
So under minus 25 there will be 1, so it's a rational number.
Very good, very good. So we can express every number in the form P by Q, because if it is 1, we can write it as 1 by 1. If it is 0, okay, I will come back to the 0. And if it is a negative number, say negative 100, we can write it as negative 100 by 1. Okay, if it is 200, we can write it as 200 by 1. So here this is negative 25 and we can just write it as negative 25 divided by 1. So the answer is yes. This is a rational number. And here comes our statement. All natural numbers are rational numbers. Okay, all natural numbers are rational numbers. Then all integers are rational numbers. Right? All whole numbers are rational numbers because we can express every number in the form this, just like this. Everywhere Q will be equal to 1. Okay, if it is 100, 100 by 1, then 200, 200 by 1, negative 25, negative 25 by 1. So all natural numbers are rational numbers, all whole numbers are rational numbers, all integers are rational numbers. All these statements are true. So here the answer is yes, because we can write it as negative 25 divided by 1. Okay, and we have a statement, all whole numbers are rational numbers. Okay, we have a statement, all whole numbers are rational numbers. Right?
Ma'am,
Yes.
can you go 2 slides back?
2 slides back. This one. Okay. So the statement is all whole numbers are rational numbers. So whole numbers means it includes 0, 1, 2, 3, 4, etc. So what about the 0? Is 0 a rational number? Okay, is 0 a rational number? Instead of this negative 25, I have 0. So is 0 a rational number?
Chris?
Yes, okay.
Chris?
Ma'am, we can write zero as 0 by 1.
Yes.
So it is a rational number.
And here we
And
have,
we can write 0 by 2, 0 by 3.
yes, very good, very good. So here, see, here P is equal to 0. The numerator is equal to 0, but that is possible. Our condition is Q not equal to 0. P can be equal to 0. So we can write the 0 by 0 by 1, 0 by 2, 0 by 3. All these are possible. Therefore, all whole numbers are rational numbers. Okay? Yeah. So here it is yes. Now, The rational numbers also include natural numbers, whole numbers and integers. Okay, all natural numbers are rational numbers, all whole numbers are rational numbers and all integers are also rational numbers. Here I can see so many hand raises. So the hand raises are for just answering or any doubts. If you don't have any doubts, please lower your hand. If you have any doubts, please raise your hand. Any hand raises, ma'am?
Yes. Abneet.
Abneet, any doubts?
No, I only want to know.
Okay, yeah, fine. Then here, Sharon, any doubt, Sharon? Do you have any doubt?
No, ma'am.
Okay, fine. So, the next topic or the next thing is, which of the following statement is true? First question, every whole number is a natural number. Yeah.
Jewel.
Yes, every whole number is a natural number.
False, ma'am. Every natural number is a whole number.
Yes. So, which is the exception? Which whole number is not a natural number? Please unmute her, ma'am.
Ma'am, 0.
0. Yeah, 0 is not a natural number. Yeah, very good. So, the statement is false. All whole numbers are not natural numbers, but every natural number is a whole number. Then the next statement, every integer is a rational number. Every integer is a rational number, ma'am. Next one.
Anaga.
Okay.
True.
True. Yeah, okay. Every integer is a rational number. We can express every integer in the form p by q. We can take any integer, negative 2 by 1, negative 25 by 1, then 2 by 1, 100 by 1. We can express every integer in the form p by q. So, every integer is a rational number. That is true. Then, every integer is a whole number.
And, this one. Ishan.
Okay. Every integer is a whole number. Is that true?
False, ma'am.
False.
That's
Why?
false, ma'am. Because it has a negative number.
Yeah, negative numbers are included. Negative numbers are not whole numbers. Very good. Okay, so very good. Now the next statement is every rational number is an integer. Is that true? Every rational number is an integer.
Rehan.
Every rational number is an integer.
No.
Or
Every integer is a rational number.
yeah, okay, every integer is a rational number, but every rational number is not an integer. We can take some 1 by 2, 1 by 3. They are not integers. Okay, they are not integers. So the statement is false. Yeah, okay. Okay, so so every rational number is an integer. That is a false statement. But if it was like every integer is a rational number, that must be true. Okay? Yeah. And now we have equivalent rational numbers. Okay, or fractions. Equivalent rational numbers. What are equivalent rational numbers? Okay. See, rational numbers do not have a unique representation in the form p by q, where p and q are integers and q not equal to 0. For example, let's take this 1 by 2. 1 by 2 is also equal to 2 by 4. That is also equal to 10 by 20. Why? Take this 2 by 4. What is the simplest form? When we cancel this 2 and 4 using 2, we will get 1 by 2. Right? So this 2 by 4 is actually equal to 1 by 2. In the simplest form, that is 1 by 2 only. When we take this 10 by 20, 10 by 20, when we cancel these two zeros, we will get it as 1 by 2. Okay, then 25 divided by 50, that is also equal to 1 by 2. Okay, 50 is 2 times 25. So this is again equal to 1 by 2. 47 divided by 94. What is 47 into 2? It is 94, right? Yeah, so this is again equal to 1 by 2. Yeah, so what we have in the denominator is actually 2 times the numerator. So all these are actually equal to 1 by 2 itself. Such fractions are known as equivalent rational numbers or equivalent fractions. Can you show the fourth question? Yeah. Every rational number is an integer. That was the fourth question. Okay. Yeah. See this? Every number or this every fraction has some equivalent fractions. If we have this 1 by 3, this is actually equal to 2 by 6. Okay. Again, this is equal to 3 by 9. For every fractions, we have equivalent fractions, which means when we simplify them, we will get the same thing, same fraction. So such fractions are known as equivalent rational numbers or equivalent fractions. And what about their representation in the number line? See, whenever we say that P by Q is a rational number or we represent P by Q on the number line, we assume that Q is not equal to 0 and P and Q have no common factors other than 1. Okay, so in the definition of rational numbers, it was given that P by Q, okay, they are in the form P by Q, where P and Q are P and Q were given as integers, okay, and Q not equal to 0. Here I am adding one more thing to this integers. They are actually co-prime integers. Okay. Should we write this? No, just understand this. Okay. Yeah. So when we say that P by Q is a rational number or when we represent P by Q on the number line, we assume that Q not equal to 0 and this P and Q are actually co-prime integers. So what are co-prime integers? We have a new word. What are co-prime integers? Let's see this. Co-prime integers. What are co-prime integers? Before that, what are prime numbers? What are prime numbers?
Eric,
Yes, Eric. What are prime numbers?
Ma'am, prime numbers, I don't know.
You don't know? Okay.
I don't know.
Yeah. Next one. Oh, okay. Next one.
Sri Lakshmi,
Okay. What are prime numbers?
Sri Lakshmi,
Yes. Please unmute.
Sunny.
You are not audible, Sri Lakshmi. No, I can't hear you.
Just unpin your headset. Sri Lakshmi,
Try to unplug your headphones and then. Ma'am, who is that? That comment. Right side? Right side. About that. Yeah.
Zuhair.
Okay, Sri Lakshmi, you are not audible. Still, you are not audible. Yeah, please unmute him.
Zuhair, can you raise your hand?
Yeah. Okay. What are prime numbers?
Ma'am, prime numbers are those numbers that cannot be divisible.
Cannot be. For example.
1, 3, 5,
Okay.
7.
Yeah.
Then
And are these prime numbers same as odd numbers?
no.
No. Okay, because we have 1, 3, 5, 7, everything. They are odd numbers, right?
Yes.
So.
But after that, it will be 11.
Oh, okay. 9 is not there.
11.
Okay, 9 is not there, right? Yeah, so what are the specialities of these numbers? Prime numbers means, what about the factors of these numbers?
Factors. Those numbers cannot be divisible, you know.
Yeah, to be precise, those numbers having only two factors, that number itself and 1, right? Why we are not taking 9? What about the factors of 9? It has got
9
1.
is is multiplied with 3.
Yeah, we can divide 9 by 3. Okay.
Yes.
Along with this 1 and 9, it has got another factor which is 3. But when we take this 3, it is 1. It has got only 1 and 3. Now, what about this 1? Is 1 a prime number?
Yes.
Sure.
Yeah.
Okay. Yeah. We have some more hand raises, so let's ask them. What are prime numbers? Your definition. Yeah, Meher.
Ma'am, prime numbers are basically numbers they don't like, for example, you forgot two there.
2 there. You forgot. I forgot 2 here. Okay.
And
Two.
they basically have, for example, if you take like 9, it has like instead of 1 into like 1 and the number itself, it doesn't have any other
Factors.
numbers.
Factors. Okay. So is 2 a prime number?
Yeah.
Yeah. Okay. What about this 1? 1 is a prime number. Okay. Yeah. It's okay. It's okay. It's okay. Yeah. Let's unmute one more person.
Haifa.
Yes, Haifa. What are prime numbers?
Prime numbers are the ones which has two factors, one and the number itself.
Okay, 1 and the number itself. So is 1 a prime number?
One is not a prime number, but there is a specific name for it.
Okay. Yeah.
Because it only has one factor, so it doesn't have a.
So,
it's not a prime number.
It is not prime. Yeah. Okay then. Very good. Yeah. Then what are composite numbers? What are composite numbers?
The Booth Mazia.
Okay. What are composite numbers?
Can you unmute?
Please unmute.
Huh?
Yes.
There are the numbers that have more than two factors.
Yeah, more than 2 factors. For example, can you tell me some examples of composite numbers?
Ma'am, for example, 9,
9. Okay.
10,
10. Yeah. 4. Yeah, some numbers. So, in case of prime numbers, let me explain this now. Prime numbers got only 2 factors. Okay, only 2 factors will be there. That number itself, okay, that number itself and 1. Okay, only 2 factors, that number itself and 1. And the examples are 2, 3, 5. All these numbers have only 2 factors, that number itself and 1. Okay. And what are composite numbers? The numbers having more than 2 factors. More than 2 factors will be there. Okay, that number itself and 1 is always there for all the numbers, and for prime numbers only that number and 1 will be the factors. But for composite numbers it has got more than 2 factors.
Ma'am, just a moment.
Yes.
Can you go back to the second last slide?
Second last. This one. Okay, if you are talking about this one, I will come back to the slide. Okay, after explaining that, I will come back to the slide. Don't worry about this one. Yeah, after explaining this core prime and everything. Core prime I will explain once again. Okay, before that you must be familiar with
The national number.
This
the
one.
equivalent rational numbers.
Okay. So before learning about this core prime numbers, you must be familiar with this prime numbers, composite numbers and everything. That's why. Yeah, so prime numbers are those numbers. Yeah, okay. Only 2 factors will be there, that number itself and 1. In case of composite numbers, more than 2 factors will be there. So what about this number 1? I have number 1 here. What about this number? If it was prime, there must be 2 factors, right? There must be 2 factors. If it is composite, there must be more than 2 factors. Yeah, who is that, ma'am? Yeah, that comment.
Maharab.
Yes, Mehrab. So, 1 is?
Neither prime nor composite.
Yeah, 1 is neither prime nor composite. It is actually a unique number. Okay, 1 is actually a unique number. It is neither prime nor composite. If it was prime, there must be 2 factors. If it was composite, there must be more than 2 factors. But here, 1 is a unique number. It is neither prime nor composite. Okay. So prime numbers are those numbers having only 2 factors, and composite numbers are those numbers having more than 2 factors, and this one is actually a unique number. How about 0? Okay, 0 is again, it's unique. We can't say anything about the factors of the 0 and all. So it is again considered as a unique number. Okay. Yeah. So prime and composite. These are prime and composite numbers. Now we have, okay. I have a statement. Every even number is a composite number. Every even number is a composite number. Is that true? Every even number is a composite number. True or false? Yes, Mars.
I'm putting my hands over like for like 30 minutes from now.
What happened? Sorry.
I was gonna say, I just want to ask like a simple question like, what new chapter is it?
Okay, this chapter is number systems. Chapter number 1. Okay.
That's what I want to ask.
Okay. So every even number is a composite number. Is it true or false?
Muhammad Shaheen.
Okay.
No, it's false. Because numbers such as 2, which is even number, it is not a composite number.
Yes.
Yeah.
2 is even, but it is prime. 2 is even, but it is prime number. So every even number is a composite number. That is a false statement. But all other even numbers are actually composite numbers. Take 4. Yeah, 6. All other even numbers except this 2, they are actually composite number. 2 is the only even prime number. Okay, 2 is the only even prime number. 2 is the only even prime number. All other even numbers, they have got this 2 as a common, like 2 as a factor. So all other even numbers are actually composite numbers. 2 is the only even prime number. So if the question is, they are not going to ask us such questions, but still, which is the smallest even prime number? Smallest even prime number. You can comment your answer. Smallest even prime number. It's 2. Okay, largest even prime number. Largest even prime number, that is also 2, because 2 is the only even prime number. So for all these questions, 2 is the answer. 2 is the only even prime number. Okay. Yeah. Now let's go back to this co-prime integers. What are co-prime integers? 2 integers are said to be co-prime if they have no common factor other than 1. So if it was a prime number, we were talking about only that number itself, like it is just 2. Okay, so 2 has got only 2 factors, 1 and 2. Then if it was 3, then it has got 3 and 1 as the factors. So that was the case of prime numbers. But here we have co-prime, and here we have 2 integers. Here we were talking about only 1 integer and the factors of that integer. But here we have 2 integers. In case of co-prime integers, we have 2 integers, and they are said to be co-prime if they have no common factor other than 1. For example, let's take 1 and 2. What are the common factors? Only 1 is the common factor. Okay, if we take 2 and 3, the only common factor is 1. But if we take 2 and 4, what are the common factors? 1 and 2 are the common factors. When we take 2 and 4, it has got 2 common factors, 1 and 2. So these 2 and 4, they are not co-prime integers. Okay, so 2 integers are said to be co-prime if they have no common factor other than 1. So what is the difference between this prime numbers and co-prime numbers? If it is prime numbers, okay, we are talking about a single number or single digit. Okay, so like single number, not digit. So if we are talking about this 27, is it prime or composite? We are only considering the factors of this 27. Okay, and here co-prime integers, we have this common factors. Okay, if two numbers has got only one as the common factor, then such numbers are co-prime numbers or co-prime integers. And if they have some common factors other than one, they are not co-prime integers. Okay, so please lower your hands if you don't have any doubts. Otherwise, please raise your hand. Okay, if you don't have any doubts, please lower your hands.
Daniel Joshua,
Yes.
any doubt?
No, teacher, I just wanted to answer.
Answer. Okay. So, any other doubts, guys?
Ashwin,
Yes, Ashwin.
turn on your camera first. Yeah, okay.
Yes, Ashwin.
Okay, repeat the question, ma'am.
No, I was asking whether you have any doubts or not. If you don't have any doubts, please
No.
lower your hands. Okay. Yeah. Okay, guys, please lower your hands if you don't have any doubts. Please.
Ruben, any doubt?
Yes. Yes, Ruben.
Yes, when I have a I didn't understand the prime numbers.
Prime numbers. Okay. So prime numbers means when we have a number, see 2. The factors of 2, which means we can write this 2 as 1 into 2, and this 1 and 2, they are known as the factors of 2. Okay, so when we consider this 2, it has only 2 factors, 1 and that number. Or you can just think it like this. You can divide 2 by 1 and 2 by 2. You cannot divide 2 by some other number, say 3, it is not possible. And when we...
Is it because that 3 is a bigger number than 2?
Bigger number, okay, so what about this 4? When we take this 4, we have this 1 into 2 and 2 into 2. Even though 3 is less than, okay, 1 into 2, no, not 1 into 2, 1 into 4 and 2 into 2. Okay, 1 into 4 and 2 into 2. Even though this 3 is less than 4, we cannot completely divide 4 by 3, right?
Yes.
Yeah, so if we have some factors, see here we can take that 1, 4 and 2 as the factors of 4. We can divide this 4 completely by 1, we can divide this 4 completely by 4, and we can divide this 4 completely by 2. So this 1, 4 and 2, they are known as the factors of this number 4. Okay, but in case of this 2, it has only 2 factors, 1 and 2. But here, in case of this 4, it has 3 factors, 1, 2 and 4. Again, you can take 5. We can only express 5 as 1 into 5. So, the only factors of 5 are 1 and 5. And you can take another example, say 10. We can express this 10 as 2 into 5, then 1 into 10. So, this 1, 10, 2 and 5 are the factors of this 10. So here see, in case of this 2 and this 5, they have only 2 factors. That number itself, 2 has a factor and 1. And this 5 has factors, 1, that number itself and 1. Such numbers are known as prime numbers. Okay? Yeah. So any other doubts, guys? No. Okay. So and here co-prime integers. After that prime numbers, we have co-prime integers. When it was a prime number, we were just talking about a 5 or a 3 or a 4, something like that. Okay, prime or composite. Yeah, but here co-prime, coexist. You have a word in biology or something like that. So coexist means together, right? Existing together. Yeah. So see, here we have co-prime. Can you explain again? I didn't understand. Promise. Please raise your hand. Which, like prime numbers? SST. Okay, thank you. Where is Promise? Yeah. Promise, can you please raise your... Yes. Prime numbers. Do you have doubts about prime numbers?
I couldn't hear what you said properly.
Prime or co-prime?
Prime numbers.
Prime numbers. Okay, prime numbers are those numbers having only 2 factors, 1 and that number itself. Okay, 1 and that number as the factors. Such numbers are known as prime numbers. For example, when we take 2, 2 has only two factors, 1 and 2. Okay, 1 and 2 are the factors of 2. When we take 5, it has only 1 and 5 as the factors. Okay, 1 and 5 as the factors. But when we take 4, we can express this 4 as 1 into 4 and 2 into 2. So it has 3 factors, 1, 2 and 4. So here in case of 4, it has 3 factors, 1, 2 and 4. So such numbers are composite numbers, more than 2 factors. Okay, more than 2 factors means they are composite numbers. If they have exactly 2 factors, that number itself, 2 has 2 as a factor and the other factor is 1. 5 has that number 5 as a factor and the other factor is 1. So such numbers are known as prime numbers, and other numbers having more than 2 factors, they are known as composite numbers. Okay?
Okay, ma'am.
Yeah. Yeah, very good. Now we have coprime. Coprime numbers. Now coprime integers are 2 integers are said to be coprime if they have no common factor other than 1. For example, when we take this 2 and 4, they have common factors. How to find these common factors? Just write the factors of 2 and 4. The factors of 2 are 1 and 2. For this 4, it has 1, 2 and 4 as the factors. So 1 is a factor, yeah, but that is allowed. If they have no common factor other than 1, so it is coprime. So here 2 is also a factor. Okay, so this 2 and 4, they have this 2 as a common factor. 1 is always there. For any numbers, any 2 numbers, 1 is always a common factor. But here 2 is also a common factor. So this 2 and 4, it's not coprime. Okay, they are not coprime integers. But when we take 1 and 3, they are coprime because the only common factors are 1 and, only common factor is 1. So 1 and 3 coprime, but 2 and 4 not coprime. We can take some more examples. 1 and 3, then 1 and any number. Okay, 1 and any number you can take. Then 2 and 7 coprime because there is no common factor. Then 3 and 5 coprime. Okay. So is it clear? Coprime integers.
Two prime numbers are coprime. Any two prime numbers.
Yeah. So any 2 prime numbers are coprime. Any 2 prime numbers. You can take any 2 prime numbers. 2 is a prime number and 5 is a prime number. They are coprime. Coprime because what are prime numbers? Those numbers having only 1 and that number as the factors. So if we take any 2 prime numbers, only 1 will be the common factor. Okay. So is it clear? Coprime. Is 11 coprime? Like you have to add one more number with that. Coprime means 2 numbers. Okay, if it is prime, the question is 11 a prime number? Yes, 11 is a prime number, but you can only ask, is 11 and some number, is that pair a coprime? Okay, you can only ask like that. Is 11 a prime number? Yeah, you can ask like that. But if it is coprime, we are talking about 2 numbers. Okay, coprime means 2 numbers must be there. Yeah. So,
Ma'am, is 8 and 11 coprime?
8 and 11, yes. 8 and 11, what are the factors of this? Yeah, let me write 8 and 11. So 8 and 11, what are the factors of 8? 1, 2, 4 and 8. These are the factors of 8. But when we come to this 11, it is a prime number actually. So the only common factor is 1. So 8 and 11 is coprime. Is 11 and 13 coprime? Yes. Any 2 prime numbers are coprime because we have only 4 prime numbers. They have got only that number and 1 as the common factors. So you can take any 2 prime numbers. That pair will be a coprime. What?
1 and 0.
Okay, we won't consider the 0 and 1 because again they are unique numbers, no? So any numbers other than this greater than 0, just consider, no, please don't consider this negative and like the 0 and all. You can just consider other numbers, okay? the numbers greater than 1. 1 is actually a unique number. It's neither prime nor composite. So that's why. Yeah, co-prime integers. Any doubts? Can you take 8 and 16? No. See, 8 and 16. Factors of 8. 1, 2, 4 and 8 are the factors of 8. When we take 16, 1, 2, 4, 8 and 16 are the factors. Here 1 is a common factor, but that is allowed. But 2 is a common factor, 4 is a common factor, 8 is a common factor. So you can't take this 8 and 16. They are not co-prime. They are not co-prime. Okay? Yeah, now let's compare to this one. When we say that...
Ma'am, one hand raise.
Yeah.
Rishikesh.
Yes, Rishikesh.
Ma'am,
9 and 11.
9 and 11. You just tell me. Is 9 and 11 co-prime?
It is not, it is co-prime.
Yeah.
It will be 1.
1 is the only common factor, right? So 9 and 11, yeah, it's co-prime.
9, it will be 1, 3, 9.
Yes. 11?
1, 11.
Okay. So it's 1 as the only common factor. Yeah. Okay, now...
Ma'am, one more hand.
Yes.
Rehan.
Yes, sir. I wanted to ask, is every group of two consecutive numbers co-prime?
What?
Is every group of two consecutive numbers co-prime?
Yeah, yes.
Numbers.
2, 3, 3, 4 consecutive numbers, they are always co-prime. Yeah. Okay. Now let's come back to this one. When we say that P by Q is a rational number, or when we represent P by Q on a number line, we assume that Q not equal to 0 and P and Q have no common factors other than 1. No common factors other than 1 means P and Q are
Ma'am, one more
co-prime.
doubt.
Yeah.
Oh, sorry. Negative numbers. Can we take negative numbers as co-prime?
Except 0 and 1. I have to check. Okay, I will tell you. Yeah, why we say that P by Q, when we say that P by Q is a rational number, or when we represent P by Q on a number line, we assume that Q not equal to 0 and P and Q have no common factors. Who is that?
Sheikh.
Sheikh? Sheikh, what are you doing there?
no, ma'am, I'm talking to the 90 plus team. They just called.
Okay. So are you listening to the class? Any doubts about any topics? Why did they call you? For the same reason, right?
What happened, ma'am?
Why did the 90 plus team call you? For the same reason, right?
No, ma'am, my camera's turned off, so that time that my camera's turned off.
Okay.
Like,
So,
ma'am, you can see the camera turned on, right?
yeah, now it's turned on.
Yes, ma'am, they've been calling for the past 3 or 4 days, annoying me and telling that my camera's turned off.
Okay, so can you please tell me what are co-prime integers? Co-prime integers.
Co-prime integers are 2, 4, 2, 5, 8.
2, 4, 2, 5, 2, 8. So, is 13 and 17 co-prime? It's not
Yes,
there in
ma'am.
your notebook. Please don't
No,
turn
ma'am.
your pages. It's not there, 13 and 17.
What, ma'am?
Yeah, just tell me, is 13 and 17 co-prime?
No, ma'am.
No, why?
Because they're not integers.
Not integers. 13 and 17 are not integers.
Yes, ma'am, they are.
So what are integers?
Ma'am, integers are rational numbers.
Integers are rational numbers. Okay, I'm not asking about that. Just tell me the integers. Like, see, what are natural numbers? Which all numbers are called natural numbers? Is it 0, 1, 2, 3, etc.?
Shape.
Yes, ma'am.
0, 1, 2, 3, etc. They are natural numbers.
No, ma'am, they are whole numbers.
Okay, thank God. So they are whole numbers. So what about natural numbers?
Ma'am, what do you mean by thank God? Do you not think I'm smart enough to know that, ma'am?
Okay, but you were so confused and you were just like looking
No,
around.
ma'am, that just makes me so depressed and sad, ma'am.
Oh, okay. But then why didn't you answer my question? What are co-prime numbers? You said this 13 and 17, they are not co-prime because they are not integers.
No, ma'am, they are not.
They are not, and
Ma'am, I
you
was confused. Ma'am, too much confusion, ma'am.
too much confusing.
Yes, ma'am, I'm too smart for all this, so I can't fit everything in my head for once in a while, ma'am.
Oh, okay. So just now we discussed about this co-prime numbers, no? So what are co-prime numbers? Thirteen and 17, they are not look here. Yeah. What are co-prime numbers? Please don't look into your notebook. Yeah, just look at me.
Ma'am,
You are on mute. Okay, so
ma'am, they are lucky numbers.
lucky numbers.
Wow.
No, ma'am, I'm just saying it. Ma'am, I don't know why my mic keeps getting unmuted for some reason, ma'am.
Okay, just read this. What are co-prime integers?
Two integers are said to be co-prime if they have no common factor other than 1.
Okay. Yeah.
That's exactly what I'm about to say, ma'am.
That exactly what you?
I was about to say, ma'am, but then you showed the slide, but no problem.
Shape.
I can see so many comments here. He muted it. Why? They are only sitting with you in every class and they are just commenting. You are just like this. Anyways, just leave this. Okay. Yeah, co-prime integers are two integers having no common factor other than 1. Okay, anyways. When we say that P by Q is a rational number, or when we represent P by Q on a number line, we say that Q not equal to 0 and P and Q have no common factors other than 1, which means P and Q are co-prime. So, see, when we have this definition of rational numbers, it was like, wait. Okay, yeah, here. A number of the form P by Q where P and Q are integers and Q not equal to 0 is a rational number. But in your class 10 textbook, you have P and Q are co-prime integers. It is there. P and Q are co-prime integers. So actually, this P and Q are not only integers, they are actually co-prime integers, which means they don't have any common factors other than this 1. So, when we come to this equivalent fractions, we say that this P and Q have no common factors other than 1. So, on the number line among the infinitely many fractions equivalent to 1 by 2. So, when we take any fraction, say 1 by 2, there are infinitely many equivalent fractions. Okay, this is equal to 2 by 4, then 3 by 6, 4 by 8. So, this 1 by 2 has got infinitely many equivalent fractions. Among them all, we will only consider this 1 by 2 to represent all of them. That is because of this definition, P and Q are co-prime. Okay. So, here we have this 1 by 2 equal to 2 by 4 equal to 10 by 20 equal to, it has infinitely many equivalent fractions. But among them all, we will only consider 1 by 2 while representing these numbers on the number line. So, that is the case of equivalent fractions. And this P and Q are co-prime. Okay. For me, number line is not there. I was just saying this number line is not there means I'm just saying this. Okay. For this equivalent fractions from all the thousands or no millions or this infinitely many equivalent fractions, we will only consider the smallest one. Okay. The simplest form. It is 1 by 2. So again, you can take 1 by 3. Again, we have this 2 by 6, 3 by 9, infinitely many equivalent fractions. And from all these, we will just consider this 1 by 3 as the number that we represent on this number line. Okay, you don't have to represent it in a number line, but still. Okay.
Some hand raises are there.
Yeah.
Mas. Mas. Muhammad Mas.
Yes, Mars, please unmute. Yeah.
Ma'am, what are like co-prime?
Co-prime. Okay, co-prime means two integers having only one as the common factor. Suppose we take 2 and 3. The factors of 2 are 1 and 2. And the factors of 3 are 1 and 3. So here the only common factor is 1, right? Yeah, and when we take this 2 and 4, here we have 1 and 2 as the factors, and here we have 1, 2 and 4 as the factors. So here 1 as a common factor, and along with 1 we have 2 as a common factor. So this 2 and 4, they are not co-prime, but this 2 and 3, they are co-prime. If the only common factor is 1, such numbers are co-prime numbers. If it has got other factors other than common factors other than 1, such numbers are not co-prime. Is it okay?
Ma'am, like what is some examples of co-prime?
Exact
Examples.
examples. Yeah, 2 and 3. They are co-prime. Then 3 and 4.
I mean, how do you know that it's co-prime?
What are the factors of 2? Just tell me, what are the factors of 2?
What is it?
Factors, which means the numbers which completely divide this 2.
The factors of 2 are it's what is this?
We can
1 and 2.
1 and 2. Yeah, 1 and 2. And what about this 3? Factors of 3.
Factors of 3 is 1 and 3.
1 and 3. And see, what are the common factors? What is common between them? Only 1 is the common factor. So they are co-prime. So I know that they are co-prime.
Correct.
Okay, again, just take 5 and 10. What are the factors of 5?
Yeah, now I remember. 5 and 10, 1 and 5.
1, 5 and 5. Yeah, common factors 1 and 5. Yes, here we have 2 and 10, but 1 and 5 are the factors. So the only common factor is 1 here in case of 2 and 3, but here they have 1 and 5 as the common factors. So they are not co-prime.
Yes.
Got it? Yeah.
Yes.
Okay. Now,
Now, Neha.
yes, Neha, any doubts?
Ma'am, actually, I have a test tomorrow. It's number system only. I have a doubt on representing the root numbers on the number line. So
Okay.
can you explain it to me at the end of the class or something?
Tomorrow when? Like exam?
In my school, ma'am, like, no,
Oh,
not
in your
exam,
school.
it's like a test,
Okay.
50 marks.
Yeah, but
Just one number. I know the other numbers, just one number.
okay, so let me see after the class. Okay?
Got it.
Yeah, okay. Then Rishikesh?
Can you take 23 and 25?
3 and 25.
23.
23 and 25.
23 and 25. Okay. What are the factors of 23?
123.
123. And what are the factors of 25?
1, 5.
1, 5, 25.
Then
Yeah.
25.
Okay, then common
What is-
factor is?
Co-prime.
Yeah, co-prime. Okay. So this one, yeah. When we say that P by Q is a rational number, or when we represent P by Q on a number line, this one. Okay, yeah, that is the case of equivalent fractions. Now we have this question. Find 5 rational numbers between 1 and 2. Okay, before that, any doubts about this topics? Any topics? Yeah, we have some hand raises, ma'am.
Nirmal.
Ma'am, nothing, ma'am. I am
Nothing.
about to answer.
Okay. Sanjit, any doubts?
No, can I answer the next question? 1 and 2?
Okay, yeah. 1 and 2, yeah.
Yes, ma'am. So, So find rational numbers between 1 and 2, ma'am. So it will be 1 by 1 and 2 by 1. So ma'am, we should multiply like this, ma'am. 1 by 1 into 6 by 6, 2 by 1 into 6 by 6.
Okay, wait, 1 by 1 and 2 by 1. Why did we take this 6? 1 by 1 into 6 by 6?
Ma'am, because then only we'll get 5 rational numbers.
Yeah, so 5 plus 1, 6. If you want to find 5 numbers, just plus 1. Yeah, okay. So 1 by 1 into 6 by 6 and 2 by 1 into 6 by 6. Okay.
Yes, ma'am. So it's going to be 6 by 6 and 12 by 6.
12 by 6. Okay.
And so the rational numbers will be 7 by 6, 8 by 6, 9 by 6, then afterwards 10 by 6, then afterwards
wait. Okay. 10 by 6 and 11 by 6. Okay. Yeah, very good. Yeah, that's it. This is the answer. So we have to find 5 rational numbers between 1 and 2. So what are rational numbers? Numbers of the form P by Q, where P and Q are co-prime integers and Q not equal to 0. And here we have 1 and 2. When we take this number line, we will just draw 1 and 2, right? But in between this 1 and 2, we have to find 5 rational numbers. Is that possible? Yeah, it's possible. There are like infinitely many numbers, rational numbers between this 1 and 2. We have to find that. For that, see, we can express any number in the form P by Q. Any number means any natural number in the form P by Q, because just below that, just write a 1. So here we have 1 and 2. Just write it as 1 by 1, and we can do more than 10. Yeah. Yes. Actually, there are infinitely many rational numbers between any two given rational numbers. 1 and 2, they are rational numbers. Between them, we can find infinitely many rational numbers. So if the question is to find 5 rational numbers, what you have to do is, first of all, just write this 1 and 2 as 1 by 1 and 2 by 1. Okay, so the given numbers are 1 and 2. Just write it as 1 by 1 and 2 by 1. Now we need to find 5 rational numbers between them, no? So just do this 5 plus 1. We need to find 5 rational numbers. So 5 plus 1 is 6. Yeah. Now, who is that, ma'am? Shaking his head. Yeah.
Never mind.
Okay, now it's fine. So we need to find 5 rational numbers between them. So 5 plus 1, 6. 1 by 1 into 6 by 6. You have to do this. Just multiply both the numbers with 6 by 6. We need to find 5 numbers. So just multiply them with 6 by 6. And can 4.333 considered as rational? Okay, we have a topic named this decimal expansion of rational numbers. So this non-terminating, recurring, non-terminating, non-recurring, and all this comes there. But still 4.33333, it's non-terminating, recurring, right? Yeah, so it's a rational number.
But it is not between 1 and 2.
Yeah. Okay, so here we need to find rational numbers between 1 and 2, not between 0 and 1. Yeah, see, anyways, 2 by 1 into 6 by 6. You have to do this, and then it will be 6 by 6 and 12 by 6. The 6 by 6 is nothing but 1, and 12 by 6 is 2. Yeah, so equivalent fractions. Here comes the importance of equivalent fractions. We need to find how did 1 and 5 come? We need to find 5 numbers between given two rational numbers. So just do this 5 plus 1. If the question is to find 10 rational numbers between 1 and 2, just do 10 plus 1, which is equal to 11. And here instead of 6 by 6, you have to multiply with 11 by 11. And here also multiply with 11 by 11. Okay, quiz time. Oh, okay, wait. So if the question is to find 5 rational numbers, just add 5 plus 1, 6. And you just multiply this 1 by 1 and 2 by 1 with 6 by 6. If the question is to find 10 rational numbers, 10 rational numbers between 1 and 2, just do 10 plus 1, which is 11, and you have to multiply this 1 by 1 and 2 by 1 with 11 by 11. Okay, if the question is to find 15 rational numbers between them, just do this 15 plus 1, it will be 16, and you have to multiply this with 16 by 16. Okay, that is how it works. Yeah, here we need to find 5 rational numbers between 1 and 2. So we can rewrite 1 and 2 as 1 by 1 and 2 by 1. We need to find 5 rational numbers. So it is 5 plus 1, 6, and we have to multiply this 1 by 1 with 6 by 6 and 2 by 1 with 6 by 6. So it will be 6 by 6 and 12 by 6. Here the denominator is same. So between them we can find numbers 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6 are the 5 numbers, rational numbers lying between 1 and 2. Okay. My sir took a portion recurring and terminating. What does it mean? Okay. It's when we divide this 1 by 2, we will get 1 by 2 is equal to 0.5. So it is ending here. But we have some other decimals like 0.5555. It goes on like this. Okay, here if it is ending at a point, we say that it is terminating. Okay, terminating. Yeah, it is ending there. Others, please don't even listen to this. Okay, it is coming. Next topic. Okay, so 0.5, it's terminating, and here it is non-terminating. It's not gonna end. It goes on and on. So that is non-terminating. And recurring means this 5 is repeating, no? 0.5555, it's repeating. So it's non-terminating, recurring, or non-terminating, repeating. Then non-terminating, non-recurring means it is not ending and the numbers are different. Like 0.54218694. It goes on and on, but the numbers are not repeating. Please don't get confused about this. We will discuss this in the class. Okay, so please don't worry about that topic.
Can you explain again?
What this one?
Ishan?
Ishan, this topic, this question, or the non-terminating, non-recurring? This question.
Yes, ma'am. Yes, ma'am. These steps.
Yeah.
I didn't understand right.
Okay, so we need to find 5 rational numbers between 1 and 2. Okay, so we just take 5 plus 1. Since we need to find 5 rational numbers, we just take 5 plus 1, 6. Okay, so we just take 6 by 6 and we multiply this 1 by 1 and 2 by 1 with this 6 by 6. Okay, just because we need to find 5 numbers between them. In between this 1 and 2, it's very difficult to find the numbers. So we are rewriting it in the fraction form, P by Q form, 1 by 1 and 2 by 1. And we need to find 5 numbers. So we just multiply this 1 by 1 and 2 by 1 with 6 by 6. Okay, 5 numbers. So we take 6 by 6 and multiply both of them with 6 by 6. Now, what is 1 by 1 into 6 by 6? We just multiply 1 into 6, that is 6. Then 1 into 6, 6. Here 2 into 6 is 12 and 1 into 6 is 6. So 6 by 6 and 12 by 6 are the two numbers. Now we need to find 5 numbers between them. The denominator is same. So between the 6 and 12 we have 7, 8, 9, 10 and 11. So these are the 5 numbers. Okay. We can put a bar on the number if it is repeating. Yes, Ibrahim, correct. Sir, AC. Okay, is it okay? Any doubts? If you don't have any doubts, please lower your hand.
Durgesh?
Yes, Durgesh, do you have any doubt?
No, I don't. Yes, ma'am. I don't have any doubt, ma'am. Like, can you show the last slide?
What?
The previous slide.
Previous slide.
Can you show the previous slide?
Like this
Not
one.
before. Like before.
Before this. Okay, this one.
Yes.
Okay. Then who's that?
Yes, ma'am.
Yeah, okay. Chris, any doubts?
Yes, ma'am, I do have. Can
Yes.
we find negative numbers between two rational numbers?
Negative numbers between two rational numbers. See, 1 and 2, they are positive. Between them, there is no negative number. between 1 and 2, like when we draw the number line, here is 1, here is 2, and all the negative numbers are here, right? Yeah, so between this 1 and 2, there are no negative numbers. They are just positive numbers. So between them, there are no negative numbers. Yeah. Okay. Then next one.
Muhammad Zahel.
Yes. Any doubts, Sahel?
No, ma'am, I have doubt in that question like 1 and 2, right?
Yeah.
So on that you did like we have to find 5 numbers, so we did like 5 plus 1, 6. So instead of doing that, can't we just do it like into 10 directly?
Yes, that is possible. You will get more numbers, and you just have to write 5 numbers. That is fine. You can just multiply it with 10 by 10 or 20 by 20. That is fine. Okay.
Yeah, okay.
Yeah.
Ma'am, can you go to the previous slide?
Previous slide. This one.
Yeah. Ma'am, like we said English, no, after that.
After.
So here you said you didn't give example like -5 and -2 can also be co-prime integers, right?
Actually, we will not consider this negative, but like in this concept, yeah, they are co-prime, but we won't actually consider that negative numbers actually.
Ma'am, but it's integers, right?
Yeah, yes. Yeah, they are co-prime.
So like if they ask if -5 and -2 is
Yes, they are co-prime. They don't have any common factor other than 1, so they are co-prime.
so negative numbers can also be under the co-prime category.
Actually, what happens is when we take this -5 and -2, it's not there. Actually, you won't get such questions. They will only ask for this positive numbers and all. Negative numbers won't be there in your question paper and all. It's there, yeah, correctly. It is actually co-prime, but yeah, co-prime. Okay. Yeah. Okay, then yes, okay.
Muhammad Zuhair.
Could we do one more question like this? Yeah, okay. Yes, okay.
Muhammad Zuhair.
Yes, ma'am. How did you get 6 by 6?
6 by 6. You can just take, we need to find 5 numbers. So, if you are taking it as 5 by 5, 4 by 5, something like that, you won't get this 5 numbers between them. So, one number greater than this 5. Or you can just take 10 by 10. Somebody was asking that doubt. Just any number greater than 5. If you want to find 6 numbers, just take 7 by 7, just take 8 by 8, or just like that. We just need to find some equivalent fractions. Okay, just to find this equivalent fractions, you just multiply this 1 by 1 with any number greater than this 5. So it can be 6 by 6, or it can be 10 by 10. It can be 20 by 20. Any number greater than 5 you can take and multiply the numerator and denominator of this given numbers with that number. Okay? Yeah.
Muhammad Shaheen.
Yes, Shaheen.
Yes, ma'am.
Any doubts?
Sorry, ma'am. I didn't realize my hand was.
Yeah.
Okay.
Yeah. Now, Rishikesh, do you have any doubt?
Can you take 5 and 12?
5 and 12. Between 5 and 12.
Yeah.
Okay, 5 rational numbers. Yeah, 5 rational numbers between 5 and 12. See?
It will be 5 plus 5 plus
Oh,
1, 6.
wait. I can write 6, 7, 8, 9, 10. They are also rational numbers. So 5 rational numbers between 5 and 12, we can just directly write the numbers, no? 5, 6, 7, 8, 9 and 10, they are already rational numbers. Even though they are natural numbers or all numbers or whatever, they are...
Can you please 5 rational numbers between 5 by 6 and 12 by 5?
We will do more questions in the next class, Rishikesh. If you have any doubts about the questions that we have discussed now, you can ask me. Okay? You can just do the, yeah, your question was like 5 by 3 and what, 6 by 3, you can just do the same thing. Multiply with some 6 by 6 or 2 by, like if you want to find numbers, 6 by 6. Just multiply with 6 by 6 and you can find the numbers. Okay, do the same thing. Even though they are fractions, you can do the same thing. We will discuss more such questions in the coming classes. Okay, next one.
Rejoy Matthew.
Yeah, okay. Yes, Rejoy.
Ma'am,
Ah.
ma'am, for the find 5 rational number question, can we multiply with 10 also?
Yes, you can do that. Any number greater than 5 is okay.
Okay.
Yeah.
And Aris.
Yes, Aris. Aris. Aris, do you have any doubts? Not there.
Who was there?
Okay, so
Amina.
yes.
Ma'am, if they tell us to find 10 rational numbers between any number,
Yeah.
so can we multiply it with 10?
No, not 10. You will get only 9 numbers. Multiply it with a number greater than 9. So just multiply it with 10, 11, some numbers like that. Okay?
11.
She asked me 10, right? Your question was to find 10 numbers. Yeah. So just multiply it with 11 by 11, 12 by 12, some numbers like that. Any number greater than 10. Okay? Yeah.
Okay.
Yes. Okay. So now it's time for exam. Sorry, please inform. Exam time. Yeah, exam time. Please refresh your page. Please refresh your page. Okay. There you can see.
No, you asked me to unmute.
What? Aris, yeah, Aris. Is there any doubt?
Ma'am, there's having some problems internet.
Okay. So do you have any doubt?
Yeah, can you explain that problem, the terminating problem?
Okay. If we have 0.5, just 0.2, 0.1, it is ending there. So they are known as terminating. Okay, it is ending. So terminating. If it is not terminating.
If it is endless, it's non-terminating.
What?
If it is like continue, if the number doesn't end,
that is non-terminating. Yes, that is non-terminating. And here, this is non-terminating and repeating. Like this 5 is repeating. So we just say non-terminating recurring or repeating. And if it is non-terminating, non-repeating, it is 0.5, 3, 4, 2, 1, 6, 9, some random numbers. It is non-terminating and non-recurring.
Non-recurring.
Yeah, non-terminating and non-recurring. Okay? Yeah. Okay guys, so it's time for exam and now here we have, can we write 0 in the form P by Q? That is the first question. Yes, no, cannot be explained, none of this. Then, which of the following statement is true? Every whole number is a natural number. Every integer is a rational number. Every rational number is an integer. Every integer is a rational number. Then, in between any two numbers, there are only one natural number, two rational numbers, infinite rational numbers, no rational number. Every rational number is a whole number, natural number, integer, real number. Now, which of the following is not an equivalent fraction of 1 by 2, 2 by 4, 10 by 20, 13 by 26 and 4 by 6? These are the 5 questions. Done 10 out of 10. Yeah, very good, very good. Okay. Six rational numbers between 0 and 1. Just do the same thing. 0 and okay, wait. 0 and 1. Just to find the 5 rational numbers between 0 and 1, do the same thing. 5 rational numbers you need to find. So any number greater than that, so 0 by 1 and 1 by 1, you can just write it as 0 by 1 and 1 by 1. Then 0 into 6 by 6 and 1 by 1 into 6 by 6. So it will be 0 and 6 by 6. So between them we have 1 by 6, 2 by 6, 3 by 6, all these numbers. Okay, 4 by 6, 5 by 6. Same. Even though they are like negative 1 and positive 1, just do the same thing. Negative 1 and 1 by 1, just to find the 6 numbers, just do 7 by 7 into 7 by 7. Okay, so it will be 1 by 1 into 7 by 7. So just do the same thing. It will be minus 1 by 7 and 7 by 7. So we have 0 by 7 or 1 by 7, 2 by 7, just like that. Okay, we can do the same thing. For any two numbers, any two integers, you can do the same thing. I misclicked 2 questions. Yeah, okay.
Rishikesh?
Yes.
I got 10 out of 10.
Yeah, very good. Many of you got 10 out of 10, right? Yeah, 8, 10. Okay.
Niranjan?
Ma'am, I have 2 questions, ma'am.
Yes, okay.
Ma'am, for the first one, ma'am, in the test, ma'am, the first question, ma'am, the one you're showing, ma'am, the P by Q, ma'am, like, they're asking, like, the P and Q can be 0.
QP can be equal to 0, but Q cannot be.
No, are they asking if, like, P and Q should be,
No.
should be the same?
No, can we write 0 in the form P by Q? You can write 0 as 0 by 1, 0 by 2. So that is the question. Can we write 0 in the form of P by Q?
Oh, okay, ma'am.
So the answer is yes.
Yes, ma'am. And also, ma'am, I forgot the second question I wanted to ask, ma'am.
Okay. So that was related to this exam question or some other?
Some other. It's a some other question.
Okay. So just think.
Like, ma'am, it's in this chapter only. Like, while you're teaching, I had a doubt, but like, not forgot.
Oh, okay.
Good.
Yeah.
Neha, any doubt?
Ma'am, I completed my exam, the test.
Okay. Yeah.
Test. And I have to ask you the question, the doubt,
Root 2.
No, 5 plus root 3 on the number line.
5 plus root 3. Yeah, the same thing. Okay, after the class I will explain, Neha. Wait. Okay.
Got it.
Yeah.
Yeah.
Okay, so guys, can we discuss the answers? First answer is yes. And which of the following statement is true? Every whole number is a natural number. Is that true? No. Every integer is a rational number. Every integer, yeah. So that is the correct statement, right? Every rational number is an integer. Yes or no? No. Then every integer is a rational number? No.
Natural.
So a natural number. Every integer is a natural number. That is also false. So the second one is correct. Okay. Yeah. In between any two numbers, there are infinite rational numbers. So the third answer is correct. Now every rational number is it is not a whole number. We haven't talked about this real numbers, but still every rational number is a whole number is false. Then every rational number is a natural number again. Then every rational number is an integer. No. So the answer is real number. Every rational number is a real number. Yeah. Which of the following is not an equivalent fraction of 1 by 2? Option number 4. Yeah, 4 by 6 is the correct answer. 4 by 6 is not an equivalent fraction of 1 by 2. Okay, others, if you have any doubts about this topics that we have discussed today, please do ask me. Any doubts? I didn't understand equivalent fraction. See, we have 1 by 2. Okay, when we multiply the numerator and denominator by 2, we will get 2 by 4. So 2 by 4 is an equivalent fraction of 1 by 2. Again, when we multiply 1 by 2 by 3, we will get 3 by 6. Okay, so 3 by 6 is also an equivalent fraction of 1 by 2. Okay, then 1 by 2 into say some number 4 by 4. So you will get 4 by 8. So this 4 by 8 is an equivalent fraction of 1 by 2. Then 1 by 2 into 10 by 10. You will get 10 by 20. So all these are equivalent fractions. Okay? Yeah. Okay, that's it. Any other doubts about today's class? Okay. So let's end this class, and Neha, please wait there. Sir, please don't end the meeting. Okay?
Neha and Samuel.
Okay, Neha and Samuel, please do wait there. Others?
Niranjan?
Yes, Niranjan?
Ma'am, I got a question I wanted to ask.
Yeah, what is the question?
Ma'am, so in the question, you said to find the rational numbers between like a specific number, right? And in that you have added one. So like in all the questions, if you want to find it, we just have to add one.
Yeah, if you want to find 5 numbers, just multiply it with 6 by 6 or any number. Okay, if you want to find 5 numbers between 1 and 3, you can just multiply it with 6 by 6 or any number greater than 5 is enough, like 10 by 10, 3 into 10 by 10, or like 1 into 20 by 20, 3 into 20 by 20. So if you want to find 5 numbers between some numbers, you can multiply the numerator and denominator of the given numbers with any number greater than 5. Not just 6, any number greater than 5. Okay?
Okay.
Yeah. Any other doubts related to today's class? No. Okay. So, sir, please don't end the meeting. Others, you can just leave. Okay? Yeah. Take care. Good night. Bye-bye. Sir, end the live. Yeah, bye-bye.